Students, next we discuss about second graph, that is VT graph. VT graph means velocity time graph. Velocity time graph. Second one, velocity time graph. So this velocity time graph gives under the area of this graph, gives velocity and it gives slope of the VT graph. Slope of the VT graph gives acceleration. Slope of the graph gives acceleration. These are two important points. One is velocity time graph, area under VT graph gives velocity, slope under VT graph gives acceleration. That you will be discussed next one. Same points in the XT graph also. So first one, if an object is at rest, then what is the representation of this graph? Same as this x-axis, y-axis. Along x-axis we can take time, but in this along y-axis we can take velocity. That's why VT graph. So if body is at rest position, its velocity becomes 0. Okay. So velocity becomes 0, then after time increase, its velocity is along the parallel to x-axis. Okay, students. Next, if an object is in uniform motion, same as t, we have to take y-axis velocity, x-axis on time. In uniform motion means velocity remains constant. That's why we have to write this is velocity is V0, then is always remains constant. So this is the representation of the object moves in uniform motion. There is no slope. This slope becomes 0, which gives velocity. Acceleration. So whenever an object is at uniform motion, velocity remains constant, then acceleration becomes 0. These are all our tells in the previous classes. Okay. Now we have to take third one. If an object is in uniform acceleration, what happens? Uniform acceleration means as time changes regularly, then velocity is also changes equally or regularly. That is, the time will be increases, then velocity is also increases linearly. That is, in this situation, the graph gives a straight line from the origin, and also the object moves some with velocity u, then the representation of graph this one. So the starting from some velocity u, the graph gives a straight line this type. The starting velocity becomes 0, the graph gives origin. That is, the graph gives straight line from the origin. Okay. Now this slope, same as this is dv and this is dt and this is theta, and we have to take slope equal to tan theta equal to dv by dt equal to acceleration. Okay. Now we have to take another case. If an object if an object is in uniform retardation. In uniform retardation means after the brakes, that is before the brakes, the velocity of the object becomes maximum, that is V naught. Now, after applied the brakes, the velocity becomes decreased, that is called retardation. In case uniform retardation, then velocity is also decreased uniformly and it finally becomes 0. Okay, students, you understand this point? Now, fifth point, the object thrown with vertically upward situation. What is the representation? Okay. Time and velocity v. Now initially the object projected vertically upward. So the initial velocity is u and its final velocity v becomes 0. Now again it is freely falling body. This is u equal to 0. Then final velocity is v and this v equal to u and this v equal to minus u. So that's why we have to represent the graph. Initially at 0 time the velocity is maximum. So we have to write this one v equal to u along the y-axis. Along the y-axis. Now the time will be increased. Its velocity becomes 0. So this is the 0. So its velocity becomes 0 linearly. Because of acceleration is a minus g and in this also minus g and this g is uniform acceleration, uniform retardation. Okay. Now its final velocity v becomes 0. At this point v becomes 0. Now again it is converted to freely falling body. That's why with u equal to 0, that is this point u equal to 0. Now the object will reach the ground with velocity same v. This v equal to minus u, that is minus u, v equal to plus u, v equal to minus u, v equal to minus u. So that's why this graph will draw this one. Okay, so this will be represent v equal to minus u. So in this situation we have to write, this is the time. So this time gives time of ascent and this time will give time of descent. And this total time of flight will be represent the downward direction. Okay students, so these are the graphs. First one xt graph we will be discussed in previous class and vt graph we will be discussed in this one. And by using this graph we have to prove one of the equations of motion s equal to ut plus half at square. Okay, students, the question is prove that s equal to ut plus half at square, or this one be also represent x equal to v naught t plus half at square. X represent s, u represent v naught, initial velocity, and the distance or displacement. And this equation of motion is proved by graphical method, by using graphical method. So proof. First of all, we consider an object is initially moves with velocity u, okay, and it's moving with uniform acceleration a. Why? Because equations of motion can taken only the object moves in the uniform acceleration, and it finally reaches to a destination point b and starting point is a, not AB. We have to take X and Y or P and Q. Okay, so that's why The total distance or displacement traveled by the object is s, and its final velocity is v, and its total time taken by this one is t, and starting time t equal to 0. These are the considerations, and this will be represented by the graph. So in the graph, this is x-axis, this is y-axis, and this is origin. Along x-axis we can take time, along y-axis we can take velocity, and in this time taken as time. Okay. Now, initially at time t equal 0, the body moves with velocity u. So this is the velocity u, having some velocity. This one is u, and this point is a. This point is a. Okay. Now, the object move with uniform acceleration. That means velocity time graph gives along a straight line, and its final velocity becomes is v. Its final velocity is v. This is v. So this is point B. This is A point, and this is B point, and this point B is nothing but Q, and this point A is nothing but P. Okay. So PQ is also right. A B. Okay. A B. Now the object time, total time taken by the object is t. That's why this is the final point. So at this point on the x-axis, which gives total time t, and this point will be represent C. Okay. So this is the AB line, straight line, and this is velocity time graph. Okay. So we have to prove displacement equal to ut plus half at square. So we have to prove displacement. So velocity time graph, that is Vt graph, area under Vt graph gives displacement. This is already discussed in previous class, that is previous topic. Okay. Once again I will repeat. This velocity time graph, in this velocity time graph, area under Vt graph gives displacement. So this situation O, A, B, C, O, area gives displacement. So this is the some typical part area. So this is adjust some distance. This is point D point. So that's why OABC gives a rectangle and ABD gives a triangle. Okay. So that is right angle triangle. So that's why we have to find the displacement by using these areas or adding. That is, displacement of the object is equal to the area under Vt graph, that is area of rectangle OADC plus area of triangle ABD. Okay. So this is shown. Next one. So write this one. Displacement is equal to area under Vt graph. Area under Vt graph. Now this area displacement is S equal to area under Vt graph. This is the curve line. So Vt graph. So we have to write area of rectangle OABC plus, and the area of triangle is area of triangle What is triangle? Area of triangle ABD. Area of triangle ABD. Now displacement S equal to area of rectangle OADC. Rectangle area formula, length into breadth. So that's why, what is the length? Length is the OC, or we have to take AD also. So this one AD equal to OD. What is its value? AD and OC. OC, not OD. OC. OC equal to is T, total time represented in the given situation. So we have to represent time. Now OA CD breadth. OA CD equal to represent velocity, initial velocity U. Initial velocity U. Now similarly, this, what is the BD value? BD value. You see this side, OA is U and OD is nothing but this one. This one. This one. Okay. So O, this point, C, B point, both are same. That's why this is U and this is V. So this is U and this is V. Now what is this BD? Is total V minus U, will get this one. That is, this value is V minus U. That is change in velocity. That is change in velocity. So BD equal to represent V minus U. Okay students. Now area of rectangle is length into breadth or breadth into length. Breadth means OA. OA into length OC. Next, plus area of triangle. Area of triangle formula is half into base into height. That is half into base. Base is the triangle ABD. In ABD, base is AD. That is AD into height. Height is BD. Is BD. Now we have to write this values. OA is U into OC. OC is represented by T. That is UT plus half into AD. AD represents T, total time, into BD. BD represents V minus U. So V minus U. So if you write U into T, UT plus half this one T into V minus U. What is V minus U? You know that acceleration A equal to change in velocity by time. Okay. So that's why change in velocity V minus U equal to AT. Okay. So that's why we have to write V minus U equal to AT. So finally S equal to UT plus half A into T, that is A T square. This is the proof. S equal to UT plus half A T square by using graphical method. Okay, thank you.